Hey, beautiful people, what's going on? Got some experiments coming in from the field on gravity. And what we've discovered is the mainstream has got it wrong again. That is what happens during a solar eclipse. So their papers suggest that gravity decreases in the path of totality, which is the umbra, which is the shadow of the moon, if you're in a 100% solar eclipse location. But they use a real primitive gravity measuring machine device. It's basically a weighted pendulum with a spring. So it's not temperature reliant. So if the temperature changes, which it usually does, which it always does during eclipse, spring's going to tighten up and tell you that gravity's lower. So I did a ball drop experiment under the last one. It was last month. And come to find out, gravity is increases. So the acceleration of gravity under 100% total eclipse happens, it accelerates, so it actually increases. Now we're going to get into why it increases. All right, here we go. Ball drop experiment confirms the gravity acceleration on Earth increases in the path of totality during a 100% solar eclipse. Gazillions of photons flowing through the penumbra lowers the gravitational pull on the sun and moon on the Earth, thus increases the acceleration of gravity on the Earth inside the umbra. All right. This won't take too long. All right, this is the primitive gravity device that they use out there in the field. Basically, gravity. This is a weighted pendulum. Here's the hinge right here, the spring, and you're bringing it out in the field, and gravity moves one way or the other. This goes up, that means the gravity's lower. This goes down, gravity's higher. Then you'll have a little meter here that comes off of this, and then with numbers on it, higher, lower. But again, it's not temperature accurate. So if you get a change in temperature on this spring, is what I theorizing is happening when they go out and do these tests during an eclipse. You're going to get a false reading, and they're going to think that gravity's lower. Now, you would think that gravity would be lower anyways, just because of the alignment of the sun and the moon pulling together. That's what people think, and so I think it's almost like they will it to go in the way that they think they understand how gravity works, and this is what happens. This is a ball drop. This is me up in my van. This is a ball drop device up here. You got two photo gates, okay, that measure the speed of the ball. So it triggers a timer, and then it shuts the timer off when it goes through the gates, and then it falls into this bucket. So during the eclipse, now it's only 2 minutes that I was in the path of totality, the 100%. So it was about 20 to 30 seconds each one. And I tested it prior. I did the ball drop 2-3 hours before the actual experiment, and I got the time. And at the beginning of the eclipse, the time dropped. So basically, it was less time for the ball to go through the two photo gates, right? So it's flying through here, bang. So it was half the time, literally half the time during the eclipse. So it's obviously an increase in acceleration, an increase of gravity during the eclipse, which is the complete opposite of all the papers published out in La La Land mainstream with their Mickey Mouse gravity meters. They don't do ball drops in the field. This is the best device for testing live gravity anyways. They don't do ball drops in the field because it's cumbersome. It's really, you got to, get a bunch of stuff. I had a bunch of tripods. If this didn't work, I was going to have to hook it up, because this line where the photo gates are attached has to be plumb and level, square plumb and level. So the ball drops between these little, photo gates. So the ball just drops through, triggers it, and then triggers a timer, and then on we go. So this is the timer right here. It's, you know, thousands, 10,000, 100,000, 10,000ths of a second. It's really accurate, okay? So we're dealing with light, things of that nature. It's just a little bit of a write up. The penumbra lowers the sun and moon's gravity G pull during the 100% solar eclipse in the umbra. G equals gravity. This is my equation. Get into that later. That is why the ball drops faster in the path of totality. Shaughnessy, 2024. Copyrighted second law. This is my second law of gravity. My first one's on the mass and on the planet at 180-degree opposite mass. Anyways, we can get into that later. But so what we're talking about here is the sun's photons, trillion, Google, whatever the hell, Googleplex, the highest number out there, photons traveling. And what happens is the photons, you know, they come across this way. This is the penumbra, and this is a massive photon flow, okay? This is the photon wave, or, you know, a particle, whatever you want to call it. They say it's, they've seen it do both, act like a wave and a particle. Now it's in here that the gravitational field gets lowered, and this is the umbra, right? So it's in this dark shadow. Now this shadow is 240,000 miles long. It starts at 2,200 mile diameter here, and it's usually about 110 mile shadow when it hits the Earth. All right, there's another picture of it. We're just going to go through the pictures and things of that nature. So in essence, you know, it's the same thing. It's the Earth, Moon, Sun, the umbra, which is where the gravitational field actually gets lowered by the flow of electrons on the outside of it. It's like a vacuum. It's pulling the gravitational field from the center of this, the center line of the umbra. Here's another great. I just throw up a bunch of pictures so you can understand what I'm talking about. Obviously, the light is going all over the place, but we look at it, we're concentrating it on these two things. The moon, the Earth would be right here, right in this location, and it's the flow of these photons. I think there's electrons in there too, but everything, but it's charged particles, you name it, is you know, creating a gravitational vacuum. Now Einstein, they did his experiment where, you know, he saw the light of a star bend around. They actually did it during an eclipse. His test, they did it during an eclipse. So they saw it bend around, you know, mass bent the light around it so you could see it. So it's only common sense. If mass is bending light, right, then the light can bend the gravitational field that's created by the mass. If they're two, you know, they work both together. So in this instance, the flow of photons is actually pulling the gravitational field center line going into the Earth. Let me get a better. Oh, we got 8 minutes. All right, here's more of it right here. So you get the sun comes here. So the flow of photons is, you know, enormous. It's got mass. We're talking about hundreds and hundreds and hundreds of thousands of miles of photons flowing in this direction. We've got so you have that flow, and that flow of photons actually distorts the gravitational field in the umbra, okay? And that's where I was with my van, right down in here, measuring it, and the ball drop actually sped up. Some of the numbers, it was so fast that it hit the bucket and bounced out. I mean, it was extremely fast. I just threw that as an anomaly, but there were some super fast anomaly, high drop numbers. That this thing was almost, almost acting like a speeding bullet, if you can believe it. But anyways, those are just anomalies. I just went with the average time, which was overall half. The time was we cut in half during the eclipse. All right, so, and this is what I'm theorizing, why would gravity increase during an eclipse? I'm theorizing that it's the photon flow around the moon that's creating a that's actually canceling out the gravitational field between the sun and the moon and the earth. So it's actually lowering the gravitational field in that umbra, as the eclipse is in 100% total eclipse time zone. All right, so this kind of gives you an idea. These umbras are out there regardless of what's going on. Here's the sun. You just see the umbras are out there doing their own thing. And then when they line up, then, when you get the sun, moon, earth line up, you get the lunar eclipse on the other back end, and then you get the solar eclipse on the front end. But anyways, these umbras are always out there. They're always out there, but it's just during eclipses that we get to see them, And so there is always a negative gravitational effect going on inside these umbras in the known universe. According to this guy, John Shaughnessy, just comes up with stuff on his own. Don't kill me for thinking. I'm just thinking here, all right? So, anyways, I'm just giving you a bunch of visuals. So this is what I'm talking about. Just say this is any planet, right? Any planet, could be the moon, right? You have, it's the flow of photons that are pulling literally a gravitational vacuum in the umbra and canceling out some of the gravitational pull between the sun and the moon and the earth. And here's a real good pic. I hope these pictures are coming out okay. Yeah. So we got the earth. You get you get the sun, the moon, and the earth right here. Again, you can see the shadows. The sun's coming in. It's enormous amount of photons flowing by. It's in the trillions, quadrillion, gazillions of photons passing this small area as an eclipse is occurring. So in essence, I'm suggesting Shaughnessy's law of gravity too, is that this flow is actually pulling the gravitational, it's canceling out the gravitational field in this area, lowering it and allowing the ball to drop faster on the surface of the earth. But again, it only drops as soon as the eclipse was over, or even started to pass by. The time rose back to where, obviously, when the eclipse was over, went back to the previous measurement. So there was, direct correlation between the eclipse and the acceleration of gravity inside the umbra. Right? Okay. All right. So, let's see what else I got. I think that's kind of another bad picture. That's the best picture I think I got. So in essence, this is the foundation for a new gravity drive potentially. It's a real, it's a real issue. It can be measured. However, you got to wait for eclipses. They don't happen every week, and you got to have you got to be wherever it is to do this, to repeat this experiment. Now, I searched high and low on anybody doing ball drop experiments during the eclipses, and I couldn't find any. All I could find is that idiot, equipment that they're using. It's not temperature, isolated. So it has a temperature variance on a spring, especially a spring. I mean, a spring's any kind of temperature differential at all, it's going to throw off the measurement. So, anyway, so I'm out there. I'm throwing some ideas out there. Doing some thinking. Don't kill me for thinking. All right. Peace out, people. Catch you on the flip side. I got some other stuff going on, but I figure this is pretty important. I like to put out the big stuff. And I'll catch you on the flip side. Have a good spring out there. Summer, winter, fall, wherever you're at.